Aloha mai kako. Thank you for joining this webinar of the American Association for Geographers. It's our fifth in our series of webinars that are our lead up into the 2024 conference, which will be held in Honolulu. And a great way for you to prepare yourself to hit the ground running when you get here for the conference. Today, our topic is Islands and Agriculture, Coevolution of Agricultural Systems and a Society here in Hawaii. And we're really delighted that we have one of the bright stars in our constellation of up and coming talent. I don't know, Noah, I think you're more than up and coming, you're there already. But Noa Lincoln is an associate professor and researcher of indigenous crops and cropping systems at the University of Hawaii at Mānoa. He's also president and co-founder of the Malakalu'ulu Cooperative, and he'll tell you all about that, I'm sure. And his objective and the focus of a lot of his activity is to bring holistic and value-laden concepts and tools to the management of our land and natural resources worldwide. Hawaiians were long forced to live within the resource constraints of a small, isolated island system, and now we realize that the Earth is humanity's island. Now, using lessons and values from the past while embracing knowledge and technologies of the present can best lead us to continued evolution into the future. So that's what Noah's activities lead to, and I'm sure today's webinar will give us some background on that. Now, you're invited to really be engaged in this by asking questions, and we'll do our best at the end, last 20 or so minutes, to get to each and every question that comes forward in the chat. So without further ado, we want to present to you today Noa Lincoln. Aloha, Noa.
Aloha Neo. Thank you for that introduction. And yeah, I think you hit exactly the major theme. We hope to kind of really frame today's talk in, of island Earth and what our island cultures and societies have to offer the world. As I think globally, we do attempt to come to grips with the limitations of our planet, and again, limitations that our ancestors have had to come to grips to, over millennia of occupying small planets in themselves, situated in the vast oceans.
No, well, your screen share is on your note again, so you want to go through that process. And while you do that, I'll remind our folks that there are some people listening and participating in today's webinar, and it's also being recorded so that you may be listening at some future date and it'll be on the website for those who are participating in the conference. So we'll have those participants here today, and those participants that we won't know about will be watching the recorded version. So to all, we wish you, bid you a fond aloha and welcome. Back to you, Noah.
Thank you. So aloha e nā kua, aloha e nā omakua, aloha e nā kupuna, aloha e nā kanaka pau. I just want to start by acknowledging our ancestors and our Earth itself as, the source of our sustenance, the source of our life, and hopefully a reminder to always keep that in the forefront of our lives and our activities and our thoughts. And I think that's a critical component of island culture is acknowledging our land, acknowledging our living spaces as, not just being essential to our own well-being, but having their own mana, their own life force, their own direction that should be acknowledged and should be incorporated into our beings. And so yeah, so we'll go ahead and hop into it. I really appreciate being here today and having the opportunity to share some of our work, both the kind of academic side of our work and a bit of how we try to incorporate that into addressing, the mounting problems, not only of our home here in Hawaii, but hopefully serving also as a model for solutions elsewhere in the world. And a lot of how we do that is, looking to our past, looking to our ancestors, and learning from the processes and the adaptations that they went through to make their island home sustainable, and not, necessarily wanting to go back to an agrarian society to we're not advocating to forsake all technologies and return to the past, but we do acknowledge that there is a lot we can learn from the trials, tribulations, and adaptations of our ancestors as they forged new unknown paths as they colonized and grew their societies on our individual islands. So I want to start with a little olelo no eau, he ali'i no ka āina, he kaua vale ke kanaka, which loosely translates to the land is chief and the people merely servants. And there's a lot of ways I interpret this particular saying, but in today's talk, we take a pretty literal translation in that the land here in Hawaii and on many islands around the world greatly shaped the behavior, the actions, the values, the norms of our island cultures. And so this talk really explores how those came to be, the coevolution of our ancestors and their island homes. And in particular, we look at it through the lens of agriculture, which anywhere in the world is a fundamental way in which humans and their environment interact. And so the application of agriculture over time and across space, we'll kind of summarize those in Hawaii and kind of discuss their manifestations, again, on the social, cultural, and knowledge systems of Hawaii. And throughout the talk, we'll incorporate aspects of Hawaiian epistemology, how our ancestors viewed the world, how they viewed their place within the world, in an attempt to communicate some of those underlying cultural perspectives regarding the relationship between āina, the land, and kanaka, or humans. And it was unrehearsed, but Uncle Neil, touched upon, again, a central framing of today's talk I would like us all to keep in mind, which really is the framing of island Earth. And so on Christmas Eve, 1972, our planet was given a gift by the Apollo mission on the way to the moon. The iconic blue marble image of a illuminated face of our Earth sitting in a sea of blackness. And from this image was really born the island Earth concept, and was released during a time of environmental activism, became a major symbol of that movement, representing the fragility, the isolation, and ultimately the vulnerability of our planet as an island in space. But I would ask us if we really understand what it means to live on an island. I would argue that in today's world, our global society, islands have really become a symbol of escapism. They're places people think of as exotic, of places that they travel to get away from the realities or the challenges of their lives, to have a good time, sip Mai Tais on the beach. And essentially, this is the exact opposite of what an island is meant to represent. They traditionally were not places to escape to. They were places that largely could not be escaped from. And so here we have perhaps, the greatest metaphor for global sustainability that I would argue is completely misinterpreted and misrepresented in people's minds. And so as we go through the talk today, I hope to introduce you a bit to the realities of what island cultures were in the past, and also what they represent today in terms of thinking about global sustainability. So islands today, again, often thought of as exotic places to escape to, represented with concepts of rural living. And yet, again, the realities is that islands today are places we cannot escape our problems. And Hawaii does have a mounting number of problems in our state. And they're problems that have to be dealt with at home. It's not like a continent where people can move on down the road, where we can shift problems to another location. There's no such thing as NIMBY when the entire island is your backyard. And so as issues develop here in the islands, there's nowhere to go. There's nowhere for our people to go. There's nowhere for our trash to go. There's nowhere for our problems to go. And they stay here in our islands. And so in the modern context, would like us to think of islands as a little bit of the canary in the coal mine. They're places where problems manifest earlier and have to find place-based solutions within our state to deal with them, because there really is no other option. So I'd like to start briefly by talking about Hawaii as a study system itself. Our islands are truly one of the greatest living laboratories on the planet. And that results from a number of simple state environmental factors that really define how our islands operate environmentally and ecologically. So if you're not familiar, Hawaii does stem from a stationary hotspot, and the tectonic drift of our plate creates a highly organized age gradient of our islands, from new lava that's literally still cooling here on Hawai'i Island, all the way up to old depleted soils, 5.5 million years old on the islands of Kauai and Ni'ihau. And these gradients are highly organized. As you go from the southeast up to the northwest, you can very predictably become older and older in terms of our volcanic substrate. And on top of these age gradient, you can overlay some of the most impressive rainfall gradients in the world. And Hawaii represents everything from true deserts, about 150 millimeters of rain per year in the Kauai region, up to some of the wettest locations on the planet, and everything in between. There's a location on the Kohala Peninsula, the northern side of Hawai'i Island, where over about a 9-mile span, a hike you can do in about 4.5 hours, you can go from, again, a true desert up to one of the wettest places of the world, and traverse essentially the entire rainfall gradient of our planet, again, in a 4.5, 5-hour hike. And there are very, very few places on the planet you can traverse that amazing ecological diversity in such a dense situation. And these fundamental factors of age and rainfall interact to create a number of secondary environmental parameters. So we can see here a very nice evolution of our island's topography as a function of both age and rainfall. And starting in the upper left, Ka'u here on Hawai'i Island, you see a nice, smooth, undissected volcanic plain, broad, sweeping plains. And as you get older or wetter, those volcanic plains start to erode and dissect. And so when you get up to Kohala on the northern end of Hawai'i Island, we can see the effects of rainfall quite clearly, where on the leeward side, on the left side of the peninsula, we still have largely an undissected volcanic plain. But on the right side, we start to see the emergence of large, deep river valleys carving into those mountainsides. And as we come down to the lower right, in northern Maui, Mauna Eeke, we start to see the further impacts of time. And now both your windward and your leeward sides of the mountain become increasingly dissected by rivers and river valleys. And as we get up to our oldest major island of Kauai, we start to see heavily dissected landscapes, entirely eroded mountainsides, forming into low coastal flats in the windward side, while the leeward side, again, remains highly dissected with lots of river valleys. Additionally, substrate age and rainfall interact to define soil characteristics and types. And here in Hawaii, we have most of the world's soil orders as our lava breaks down under different environmental conditions. Our single source basalt kind of diverges into a broad range of soil types. And these soils offer different fertility, different characteristics in terms of structural stability, water holding capacity, and consequently, how productive or fertile they are. And so these different climates, topographies, and soils we see in our islands drive ecosystem diversity. And Hawaii is arguably one of the most ecologically diverse and dense locations on our planet. On Hawai'i Island alone, shown here, we have 2/3 of the world's holdridge life zones. And that number expands if you take the island chain into consideration. And so both in terms of the overall diversity, but more importantly, the density and the organization of these ecosystems means that Hawaii is a phenomenal study system in terms of understanding how species adapt and evolve to different ecosystems. And as Darwin postulated, this ecological diversity drives functional diversity, drives biological diversity. And so while the Galapagos finches are a famous example of adaptive radiation, divergent evolution, where a single species of finch diverged into a number of new unique species as it spread out across the different ecosystems of the Galapagos, Hawaii dwarfs that example. And our honey creepers also derive from a single ancestral species of finch, diversified into some 54 different unique species across the island chain. And in the conservation world, this is a very well acknowledged fact that Hawaii's ecosystem diversity relates very strongly to the diversity of species and functional traits. However, we often stop there and we don't take the next step to think that humans are no different, that when our ancestors settled the islands and spread out across these diverse ecosystems our islands offer, they were also evolving, they were also adapting. Not speciating per se, but certainly evolving their knowledge systems, their values, their practices to adapt to these unique ecosystems. And as Neil loves to ask in many of his talks, when did Hawaiians become Hawaiian? For when they stepped off the first canoe onto our shores, they were not uniquely Hawaiian, but they were Marquesan or Samoan, wherever they arrived from, bringing those cultural values and norms with them. But it's really over time, interacting with the place, that they had to adapt, they had to evolve, they had to change. And this is what truly made them uniquely Hawaiian in practice, in language, in values. And so this coevolution of people in place, again, is really what this talk is about. So I want to spend a brief moment talking about the temporal changes that happened in Hawaii. Because oftentimes when we talk about Hawaiian culture or Hawaiian practices, we often look at 1778. We look at that moment of European contact and often like to define our practices in terms of what was happening at that moment in time. But the reality is that the culture was not static. It evolved. And so it's important to acknowledge that these changes over time were an important component of where we ended up. Particularly in the case of agriculture, a lot of the practices are accumulated landscapes. What one generation does on the landscape begins to affect the subsequent generations, what their options are, what infrastructure has been built out. And so understanding the trajectory is a key component to discussing where we are. So when our ancestors first stepped off the canoe, I think it's very important to acknowledge that what they found is quite different than most of the Pacific. In the South Pacific, Tahiti, Marquesas, Samoa, Tonga, Cook Islands, Rarotonga, many of the islands are much smaller, much older, and essentially a very, very different landscape than we find in most of Hawaii. And a landscape view like this of Kohala Mountain on Hawai'i Island, broad, sweeping volcanic plains, high mountains that traversed above the inversion zone, these are not common features found in the South Pacific. And so while our ancestors brought with them a lot of knowledge and practices, there were entirely new landscapes that were unfamiliar, and they had to develop new, unique practices to make use of these landscapes in efficient ways. And when you first hop off a canoe, I assume I have never colonized an island myself, but you have a relatively small workforce. And so you don't hop off a canoe and start building out large-scale infrastructure and changing the landscape in significant ways. But particularly in that early colonization period, you have to work with the existing ecosystems to generate your resources, generate your food and fiber, in ways that do not take large-scale ecosystem change. And so when we look in our deep mo'olelo, the stories that relate to the earliest time periods in Hawaii, we find a lot of stories that talk about the forest and forest agriculture. When we look at the stories of Kane and Kanaloa, they initially settle in the river valley of Waipio. And rather than persisting on the kalo plant, which subsequently becomes the staple crop of Hawaii, we hear a lot about banana. There are stories about Luanu'u, one of the first people, one of the first kanaka in Hawaii, and how he dwelt in the edges of the forest and mingled with the navau, the forest spirits, and the mu people who lived in the forest as well. And these people were called the mu'ai mai'a, the banana-eating mu. And essentially, in these early stages, our ancestors weren't engaged in formal agriculture necessarily, that they were converting patches of forest, that they were planting shade-tolerant crops within the understory, and largely persisting on crops that could be grown in agroforestry systems, with banana being a major food component in these early stages. But over time, successive generations pass, the population grows, and you come to a point where there is more opportunity, there's more labor, there's more organization, and more substantial investments into the landscape start to be made. And so when we look in our genealogies, you will find Wakea. And in Hawaii, Wakea is most typically thought of as a deity, the sky father. And the birth of the kalo plant originates with Wakea. His stillborn child with one of his wives was buried, and from that stillborn emerges the first haloa, the first kalo plant. And he subsequently has other children that go on to become the original ali'i lines, the chiefly lines of Hawaii. But Wakea is not just a deity. Wakea is an individual found in the genealogies of Hawaii. And Wakea occurs, I believe, around the 12th generation of settlement in Hawaii. And he is associated with a number of things. He's associated with the establishment of the first political boundaries. He's associated with being a great leader and bringing about organization of his clan. And he is also associated with the aikapu, the eating taboo. And of particular interest in the aikapu is one of the foods forbidden is banana. Certain types of banana for women. And so when I hear these combinations of our genealogical stories and our cosmological stories, what I hear is that around the 12th generation of Hawaii, a great leader emerged who brought about large-scale social organization, enacted great infrastructural works, and began to transform the landscape, shifting more to kalo production by investing in building out lo'i kalo, which are flooded, irrigated terraces for the growing of kalo. And at this stage, supported by the archaeological record, we see a rapid build out of preferential areas across the state. So in particular, the lowland valleys where you have a nice freshwater source. These rivers were managed, waters were diverted through flooded, irrigated agriculture, and highly productive systems of agriculture emerge. And over about a 200-year period, we see a very rapid build out of these systems in our river valleys across the state. So this investment in agriculture has feedback. Now we're growing more food, you can feed more people, your population grows, and at some point, you kind of start to occupy all of these really prime areas, these nice river valleys, and people have to spread out further. And as they moved out of these river valleys, they started to develop other ecosystems as well. And starting around the 1400s, we start to see the large-scale build-out of vast dryland systems. So these were situated in areas where you had good rainfall, high soil fertility, extremely fertile lands, and then we see the investment again in developing highly extensive infrastructure to grow dryland agricultural crops. And these systems, again, very substantial. The Kona system, the Ka'u system are estimated to be about 60 square miles of nonstop agricultural infrastructure. And vast developments of these kind of fertile sweet spots across the state. And again, more food, population grows. Eventually, we start to fill out these really fertile ecological niches, and we have to push out even further. And so later in the sequence, starting more in the 1600s, we start to see the development of more marginal habitats, areas that are more rocky, more dry, less fertile. And we see tremendous innovation in terms of developing systems that are productive in these more marginal habitats. And the result is that when we look at even a single mountain in our island chain, Kohala Mountain shown here, we see a tremendous diversity of agroecological systems emerge across the diverse ecosystems that the island offers. And so again, we see these lo'i systems, the flooded irrigated systems in the river valleys. We see the development of intensive rain-fed systems in the high soil fertility of the leeward systems, the development of opportunistic ag in these marginal habitats, of agroforestry systems in areas of low soil fertility, and this tremendous adaptation of practice to the ecology of the landscape, so that there was no one size fits all in terms of what was done, but there was constant consideration of the land in the decision of how food was procured. And this is an important aspect of island sustainability. For if in these wet, infertile soils on the leeward plains, the windward plains, if we had tried to do intensive rain-fed agriculture there, you would be met with low yields and high erosion rates, and essentially have systems collapse quite rapidly. And so this evolution, this adaptation of systems, in large part is what allowed the sustainability of food production over time. And so the science behind this is really quite strong. And we're able to think about conceptually where these different systems fit on the landscape. And by dividing the landscape into kind of simple ecological niches, we can quite well predict where our ancestors were going to do what form of agriculture. And recently, this has moved from the conceptual into the data-driven assessments. And so the first one to do that was Peter Vitusic from Stanford University. And they looked in particular at the Kohala field system, one of the leeward dryland systems. And what they were able to illustrate is the ecological parameters that bounded these systems. And so when they looked at the situation of these dryland systems, what they found was that when they looked at the Mackay border, these two lines on the left here, the systems generally aligned in terms of annual precipitation. And this is a pretty straightforward story, that below that point, it's too dry. You can't grow crops if you don't have water. And so when we look at all the dryland systems across the state, we find that they all cut off right about that 750 millimeter mark. And that was kind of the environmental limitation that allowed the expansion of those systems. But when we look at the Mauka edge, the wetter edge of these systems, we tend to see that they cut off at very different rainfalls. And this is just showing two of the systems, but the pattern holds as you look at more, that there's no alignment of rainfall and the upper boundaries of these systems. But where they do align is when we start to look at soil fertility. And that essentially there is a fertility cutoff, and going below a certain soil performance, it's no longer worth investing in those agricultural systems because their yields begin to drop off. And so in a really clear sense, we can see how our ancestors bounded their systems to the environment, on one end by rainfall, and on another end by the parameters and characteristics of the soil. And obviously they weren't soil scientists. They didn't understand per se that the soil biogeochemistry had tremendous shifts in the uplands, but nonetheless, they followed these soil parameters on the landscape to a T. And it's really, really quite impressive how they follow these invisible gradients in soil fertility. And so we can begin to look at the adaptation of these systems in more diverse ways. And give you one example of a study our lab did a couple years ago, looking at a particular agricultural system known as the Pakukui. And these were large agroforestry systems famous for existing in the Hamakua coast of the Big Island, where they would grow kukui, known as candlenut, and they would grow kukui specifically with the purpose of cutting it down and mulching large pits in order to grow kalo. And there's great ethnographic descriptions of these systems, talking about their tremendous productivity of producing kalo weighing 20 pounds or more, and growing 9 to 7 feet high. And when we looked at the distribution of these systems on the coast, we saw several patterns that we found very interesting. So in this image here, all these yellow dots are the kukui trees that are remnant on the landscape. And a poor, unfortunate undergrad spent many hours poring through aerial imagery, hand clicking on some 27,000 kukui trees that were identified on the landscape. And what we also did was we surveyed every river and rivulet going from Hilo in the south up to Waipio Valley in the north, and surveyed the other agroforestry trees. And so in this image, the green dots, the large green dots, are breadfruit, another large staple tree. And what we found as we looked on the landscape, you can see the green dots are prevalent starting in the south at Hilo, all the way up the coast, about halfway, till you get up to this point, about halfway up the coast. And the entire rest of the coast, we identified not a single breadfruit tree. And so our subsequent analysis looked at the distribution of kukui in the north, where there was no breadfruit, and in the south, where there was breadfruit. And we found a number of interesting patterns. Oh, there's the north and the south. First of all, the distribution of kukui on the landscape changed significantly from an average of about 650 meters elevation down to about 350 meters elevation. And so there was a substantial shift in how the landscape was being used, not just in terms of including breadfruit, but in the distribution of the landscape that they were using. And when we look at soil fertility along that same cutoff, we see right at that point, right where they stop growing breadfruit and they start using more of the landscape for kukui, we see a tremendous increase, a break point in the soil fertility of the landscape. And all of this occurs at a very significant political division known as Humu'ula. And this ahupua'a is the only ahupua'a that extends all the way up to the summit of the mountain. And this ahupua'a was a political breakpoint between the Hilo moku, the Hilo region in the south, and the Hamakua region in the north. And so we can literally see the coming together of shifts in the environment in terms of soil fertility and rainfall, shifts in the applications on the ground in terms of how that landscape's being used, and shifts in the political divisions. And essentially the story we see here is adaptation of how our societies were drawing lines on the landscape that related to the performance and the parameters of the environment. So as we start to look at these socio-political divisions, we begin to see how our ancestors thought about managing the land in terms of its environmental performance. And this is work by Kavika Winters et al., 2018, displaying the moku, or our regions, overlaid on top of a representation of the ecotones of the island of Kauai. And visually, you can see how the political regions defined by these large black lines align quite closely with the large-scale shifts in the ecology of the landscape. And as per our previous example, these shifts in the ecology of the landscape accompany large-scale shifts in the types of agriculture and land usage that were applied to those regions. And so we see very strong alignment between how our ancestors divided the land politically, how they utilized the land, and how that land performs in terms of its ecology. As we move forward in time, these moku are further divided into sub-political regions known as ahupua'a. And if this is the fifth in the series, I'm sure you've heard of ahupua'a by now, but we're essentially ridge to reef divisions that contained largely self-sufficient political units that managed their resources to procure what was necessary for those social groups. And so I won't dwell too much on the ahupua'a. but there is some really, really good resources out there that describe the localized management systems. But the main point I want to make is that ahupua'a, which have been characterized as pie-sliced units extending from the mountain to the sea, were by no means uniform. As we've already discussed, the ecology of Hawaii is so different, so diverse. And as you went to a dry leeward location versus a wet windward valley, the layout, the function, and the management of the ahupua'a were extremely different and tailored to the individual resource needs of each location. And just to kind of complete the land boundary story, just wanted to share with you that although oftentimes people talk about the ahupua'a as a fundamental land management unit, the reality was there is a smaller unit that I would argue was an even more significant unit. And this is the ili. And the ili, depicted in the smallest panel here, were essentially the extended family units. They were the on-the-ground management unit where many of the decision makings around how the land was managed was made. And so this nested hierarchy of land divisions from the ili to the ahupua'a to the moku really defined the collective agriculture realities that occurred on the ground. Just looking at the time here. So I think we have enough. So I want to give one more example. Oh, didn't change the label. But an example of the Kona area on Hawai'i Island, where we again see some of the implementation of land use decisions occurring on the ground. And when we look at the landscape level of Kona, we see clearly defined agroecological zones as you traversed up the mountain. And so in the low, dry areas along the shoreline, you had what was known as the Kula Plains. And here was largely procured resource crops, things like pili grass used for thatching, hala or screw pine used for weaving, coconut, noni, crops that were not an essential part of the food supply, but were an important component of the resources and fiber crops of our ancestors. As you traversed up the mountain, you came to the kalu'ulu, or a large breadfruit agroforestry system. Here you were in a mesic habitat where you had pretty large year-to-year variations in the rainfall. You also had fairly poor soil development because there wasn't quite enough moisture. And so we see the implementation of an agroforestry system that maximized the utility of a highly variable landscape. Traversing further up, you were in the āpa'a, and this was kind of the sweet spot of Kona. You had adequate, consistent rainfall that drove the development of deeper, more fertile soils. And here, very heavy investment into the landscape was made. A lot of rock work, a lot of terracing. And this was the really intensively farmed zone of Kona, where a lot of the staple crops, kalo, sweet potato, yams, banana, were grown. Finally, as you went further up the hill, you ended up in the Ama'u. And now, as you go higher up the mountain, the rainfall gets even higher and in fact gets excessive. And what happens is that high rainfall leaches out the soil nutrients and makes it so that you can't really practice that intensive agriculture that was conducted in the Apa'a, as we saw in the work by Vatusic. And so in this Ama'u zone, you had another agroforestry system that took advantage of the native ecosystem to plant in the understory of our native canopy trees. And those native canopy trees with their deep roots, they're able to suck nutrients up from deeper in the profile, redistribute them to the surface via leaf litter, and provide enough fertility, enough nutrient cycling to support the production in the understory of some food crops, such as banana and yams. And so we took an intensive look at one particular zone, the Kala'ulu, in an effort to understand some of the decision-making processes that went in to why was this zone exactly where it was. And you can see on this 1827 drawing by one of the missionaries' daughters, depicting that Kala'ulu, this belt of trees cutting across the landscape in Kona. And we did a number of mixed methods. We used a lot of old historical maps that were geo-referenced on 3D digital landscapes. We performed an extensive number of surveys documenting remnant trees on the landscape. We looked a lot at the ethnographic descriptions of the belt, as well as looking at soil patterns on the landscape. And bringing all that together, we were able to create what we believe is a quite accurate model of the extent of that Kala'ulu system in Kona. And as we began to look at where it was and why it was there, we saw a number of patterns. So overlaying, so first of all, we see that the Kala'ulu cuts across 27 individual ahupua'a. And so there was some political oversight in the establishment of the Kala'ulu zone. These were not all independent decisions, or it seems unlikely that 27 independent ahupua'a would make the exact same decision to do this. And we see that the system itself is situated on an ahupua'a, the Kahalu'u ahupua'a that goes up to the uplands and then umbrellas all these other ahupua'a. And this generally is thought to be indicative that there was some political oversight of this central ahupua'a over the other 27. So suggesting some degree of political control and decision-making. When we look at the northern boundary and we overlay habitat modeling for breadfruit, we see that they actually align quite well, so that they were growing breadfruit as far to the north as they were able to. Basically, as you wrap around Hualalai Mountain there, the rainfall drops off quite rapidly and becomes insignificant or not significant enough for breadfruit cultivation. And in the south, again, looking at the habitat mapping, they could have kept going. Breadfruit habitat continues quite fine as you proceed south. And finally, when we look at the Mackay border, the oceanside border, we see that the extent of the system aligns quite well with the habitat of breadfruit. But when we look at the uphill side of the system, we see that they're only using about half of the breadfruit habitat, that they could have extended the breadfruit system further uphill. And yet there was this decision to not do that. Instead, they transitioned to that Apa'a zone. And so again, when we bring together all these different pieces, we see multiple decision-making factors going into the distribution of these systems. We see a hard environmental limitation on the Makai edge. We see what we interpret as a cultural preference on the Mauka edge, where you would rather grow kalo and sweet potato and not exclusively grow breadfruit, and therefore transitioned again from the kalaulu to the apa'a, where they could grow some of these more favorable crops. We clearly see political feedback defining some of the extent of these systems. And we also see, I think, quite deep knowledge in terms of how these systems were implemented and where they were situated. And we could go further into that maybe in the questions, but it's hard to talk about that in our remaining time. So when we look at our archipelago as a whole, island evolution, we have been doing extensive work to look at the distribution of soil fertility and also the distribution of our traditional systems. So we tend to use a broad degree of mixed methods, looking at the archaeology, looking at historical depictions, looking at the ethnography, and doing broad botanical surveys to understand the remnant footprints on the landscape today. And bringing all that together, we're able to depict, at least in broad strokes, the distribution of our ancestors' agricultural systems across the state. And using multiple validation methods, we are able to determine that these models are on the order of 85 to 90% accurate, demonstrating that, you know, we can use Hawaii, again, as this amazing model system to look in very detailed ways how our ancestors were applying agroecology on the landscape. And how that plays out in the data is that our islands evolve. And this is just looking at total land area against substrate age. And basically, our islands follow a perfect log linear relationship that as you get older, you get smaller. But when we look at how our ancestors utilize that landscape, it's actually kind of a bi-exponential relationship, that our younger habitats are pretty good, they're okay for agriculture. And as your islands age, you kind of hit a sweet spot where the landscape and the landscape parameters are ideal for agriculture. And we see tremendously high usage, up to 60% of the total land area being converted over to agricultural production. And then as our islands age and soil fertility declines, we see a precipitous drop in how much agriculture our islands can support. And so not only does total agriculture change, but the form that agriculture takes evolves over time. When we look at the dryland agriculture, this intensive rain-fed agriculture, we see that it greatly favors the younger islands, where the soils are younger, they're more fertile, they're able to support intensive cultivation. And here's where we get, you know, the really intensive production systems on dry land, kind of the Midwest of Hawaii, if you will. But as our islands age and our soil fertility declines, those systems are no longer able to be supported and essentially drop off about halfway through our island evolution. The flooded irrigated systems of the Lo'ikalo have a slightly longer residence time in terms of our island evolution. And those really peak in our mid-aged islands, Oahu, Molokai, and to a lesser extent, Kauai, where you have a lot of these deep river valleys that can support the flooded terraces. And then when we look at our agroforestry systems, on the bottom, we do see that in particular, kind of the really low intensity agricultural or agroforestry management really becomes the dominant norm as our islands get older and older. And so we see tremendous adaptation in terms of situating these different production systems across our island chain. And that translates to agricultural yields and where our major population centers would be. And these have tremendous manifestations in terms of our cultural norms, in terms of how the societies operated on a day-to-day level. And just a couple examples to illustrate that before I run out of time here. If we look at something as simple as land tenure, when we look at a young productive system like Kona on Hawai'i Island versus an old system on Kauai, we see a tremendous difference in how land tenure is divided. On Kauai, most families were awarded 2 separate land parcels, a parcel near the coast where they typically lived and an inland parcel for agriculture. But when we look at Kona, the average family award is closer to 4 land parcels. Again, a parcel at the coast where many times people lived, a parcel in the Kalaulu where you could have breadfruit production, a parcel in the Apa'a where you could have your kalo and sweet potato and banana production, and a parcel in the Ama'u where you could gather forest resources as well. These also manifest in 100 other ways. The different systems were dependent on different crops. In the Kohala region on Hawai'i Islands, sweet potato was dominant. Whereas if you go up to windward Oahu, kalo was the dominant crop. And these changed diet, they changed nutrition, they changed the dominant deities you prayed to. They changed the timing and vulnerability of production. And all of these things accumulate to manifest in quite different cultural norms as you moved across Hawaii. And I do think this is an important point, because as we've come in to the modern time, we tend to think of Hawaiians, as a single common cultural group. And indeed, there are many shared values, many similarities as you go across the islands. But I would say until European contact, many family groups did not think of ourselves as Hawaiian. You know, they thought of themselves as Kauaian or Mauians, you know, that they recognized they were unique in their practice and their norms, and defined themselves as such. And you see that even in a lot of the I would say more teasing Olelo no Eau. One of my favorites is in Kula on Maui. They're described as the scalers of squid because of a time when a princess of Kula was brought a squid and she didn't know what to do with it, because she lived so far upland, so far inland on Maui. She had not experienced the ocean in the same way that other groups did. And this, I think, just speaks to, again, the fact that there was tremendous cultural divergence, tremendous adaptation in how we behaved and how we managed our resources because of this tremendous ecological diversity that our islands represent. So just in closing, a couple, I guess, take-homes I just want to highlight. One, again, is just the extreme place adaptation of our practices. And I believe this is a tremendous lesson in terms of our global sustainability as well. When we look at agriculture around the world and how a Eurocentric model of agriculture, which grew out of the cultivation of grasses, of barley, of wheat, of oat, has come to dominate what we think of as how agriculture can and should be done. But when we look at Hawaii, and indeed, I think indigenous cultures globally, we see a tremendous diversity of how agriculture is implemented. And we see those practices being done in accordance with the local ecology. And if we really want to move towards sustainable agriculture, that has to be a central tenet in our consideration of our food production systems. There is not a one-size-fits-all version of agriculture because ecosystems function differently. I think another important takeaway I like to highlight is that, and you can see from looking at this image, our ancestors changed the landscape considerably. And I feel there's a very strong narrative in Hawaii of that our ancestors walked lightly on the landscape, that they were able to sustain ecosystem function and sustain their production systems because they didn't change things too much. I really think our work shows that our ancestors changed things tremendously. And it's not that they were walking lightly, they were walking intelligently. They were changing things in a way that worked with the local ecology and maintained, or in some cases, potentially enhanced the ecosystem function of those systems. And again, I believe that this is something that needs to be considered as we move towards global sustainability. Viewing any system from a single output, viewing agriculture as purely a food producing system is not the right perspective. But viewing it as a system that has multiple outputs, yes, it produces food, but it also produces ecosystem services. It also produces jobs. It also produces opportunities to express culture. We need to look at these multiple bottom lines and multiple outcomes to walk intelligently on our landscapes. And so when we look at what is indigenous agriculture today, this was just a word cloud from a study we did asking a few dozen practitioners across the state, how do you define indigenous ag today? And what we see is, I think, both land and people. And we see this multiple bottom line component of we need to produce systems that support people, but we cannot ignore the land in those systems. And walking those balance and finding a way that allows us to persist, but not at the expense of our land and our other relatives on the land, I think is a critical component, again, to moving forward. And so in conclusion, I'd just like to say that, our islands are small when we look at the grand scheme of our global society. But I would argue that it's exactly because we are small that allows big ideas to be developed. Because we were small and we had to live within those confines, our ancestors observed and evolved and adapted place-based systems that allowed them to persist. And similarly today, I think that our smallness as islands will allow us to find and pilot and demonstrate solutions that can be scaled up and can be models for global sustainability as well. And so just to end, just want us again to be reminded of the framing and the framework of Island Earth, and to, during your time in Hawaii, think about what that means, to think about what an island truly is and what it means to live on Island Earth. And with that, I'll say mahalo nui for coming and listening, and turn it back over to our MC.
No, the great gratitude is from us to you, Noah. That was amazing. I really appreciate it. If this were live, you would hear thunderous applause and appreciation for what you've shared with us. We have about a little over 15 minutes, which is great because we have some questions here that I'd like to pass on. First from Russell Fielding. Noah, what historical or contemporary, I suppose, data do we have to know the Ahupua'a boundaries so precisely?
Hey Russell, good to see you. But there's a number of resources, and luckily I think there was a tremendous amount of mapping that was done in the very early stages of Hawaii's post-European contact. And so, for instance, we just finished the project of geo-referencing about 2,000 maps that date to the 1800s. And we were doing it to extract agricultural data, but a huge amount of those maps depict Ahupua'a boundaries. And I believe in 1836, there was a early survey that mapped all the Ahupua'a across the state. And so colleague Kamana Beamer and some of his collaborators have done a lot of work on this. Some of the Bishop Museum anthropology has done quite a bit of work. But yeah, the short answer is they're literally mapped. And it's fascinating to look at these old maps and see what the landmarks were for the Ahupua'a. And if you zoom in on the Ahupua'a and you look at them, they're never straight lines from, the coast to the mountain. They're often like these little kinked boundaries. And that's because the markers are often like, well, you go from this, mound of stones to this hollow grove, and that's a straight line. And then you go from this hollow grove, up to this, large, precipice rock sticking out of the mountain. And so you have these both botanical and geologic features that are described orally, and those were the defining characteristics that were then later, with the help of Hawaiians on the ground, eventually mapped, and those maps are still well preserved.
Thank you, Noah. I'm going to combine a couple questions, one from the audience, from Francisco Lasso. This is fascinating. Thank you for this presentation. How have modern industrial methods influenced this analysis of soil fertility and island age. And then also build on that with my own question that, when we talk about lines being drawn on the basis of environmental performance, how is that different from how in a post-contact society we've drawn lines and created land use districts and created zoning designations? And again, what was, when you drew those lines differently and based on different kinds of criteria, how did it influence, go back to Francisco's question, the soils and the island's performance in terms of its ability to sustain a population?
Mm-hmm. Yeah, no, I mean, those are really good questions. And I mean, I think you hit the nail on the head. The criteria you use is going to define your outcomes. And so to relate to Francisca's question, for instance, a lot of the early soil classification work from a Western science perspective in Hawaii was based on fertilizer response as the defining parameter of soil quality. So you weren't looking necessarily at soil performance under natural conditions. You were already defining it as a response to human management of fertilization. So now, as we fast forward and we realize, oh man, fertilization has a lot of downsides, right? It's extremely energy intensive to make nitrogen fertilizer. It's extremely ecological damaging to mine phosphorus. But now we've created a system based on the criteria of soil quality is equated to its ability to retain fertilizer. So we've embedded this cultural norm of fertilization into our zoning of important ag lands. And because we've defined it on those criteria, like we've kind of locked ourselves into then, elevating those practices. So if we are globally deciding that, man, fertilizers might not be all they're cracked up to be, they have a lot of positives, but they have a lot of negatives. If we want to shift our practices away from fertilization, but our land zoning is locked in, to the criteria of fertilization, that, is going to start to create inefficiencies. And yeah, so I mean, I think you kind of answered your own question by throwing the word criteria in there. Like that defines everything, because what you put in is what you're going to get out. And so it's in some ways it's not different, but the underlying value sets and underlying criteria are different.
I always talk about ahupua'a, and so one of the things that's embedded in that is the investment horizon, and that in horizon took it into consideration the long-term effect of what you do to affect environmental performance. And that's the basis of that intelligence I think you referenced when you said we walked intelligently on the land, because we did amend it. We did manipulate things to improve performance, but with an investment horizon that recognized how's this going to work out 7 generations from now. And I think that's where the difference is in criteria, weighting, and so forth. Let's get on to another question from an anonymous attendee. How do we continue to disrupt the false binaries, and we might say romanticism, that mainland people might impose on Hawaiian history and current ecologies? Like the example of assuming 2 choices of treading lightly versus being destructive. Instead, as you state, being bold, making significant change, but treading intelligently. Is combating this simplistic thinking as simple as observing and working with the land in more attentive ways? So we're building on the discussion we just had, and maybe you can weave in some of the discussion that's going on right now about Lahaina. And I know I'm going to be moderating you again in a panel at next week at the CNHA conference. But we're looking at Kamalu'urolele and some of the historical values and practices we had, and finding a way to use that to inform, change and in creating in an opportunity that's tragically before us of rebuilding and creating new values, or in a place that needs to be restored.
Yeah, I mean that brings to mind, I think, another Olelo no Iao from Aotearoa, he aha ka mea nui, he kanaka, he kanaka, he kanaka. What is the most important thing? It is people, it is people, it is people. And I mean, I think to get away from those false dichotomies, I think protocol is an important component to always take time, I guess, to step back and remember, what is it are we striving for? And I feel in our modern society, we use a lot of highly imperfect measurements to try to gauge where we're at in terms of well-being. So we use GDP, right, or economic indicators to evaluate, quality of life in a way, but they're not at all equal. A pandemic or a war can increase GDP, but that's not pushing us towards quality of life. And what I find, most valuable about protocol is that protocol always takes a moment to situate us and takes that time to acknowledge, why are we here? What are we trying to achieve? Like, where do we really want to get to? What are we working towards? And I would argue that if you take the time to do that, most people will come to the very similar conclusions of wanting to be happy, wanting to feel safe, wanting to feel loved. And if we can start from those pieces of what are we truly trying to obtain, and setting that as the intention for all the subsequent conversations, then I think that helps to get away from those dichotomies and focus on the outcomes that we generally want to create.
And I would argue and add that, and how does these feelings, these things that we want, endure past our own generation and lifetime to our children and our heirs and so forth. Mm-hmm. One more question, a little bit more logistical. Thank you for the great presentation. This is from Hong Yang. Are any of the data and maps available online for public access?
Yes. Yeah. So yeah, most of all the papers are available open access, and looking for a way maybe to put my email out there. Yeah, all the underlying data, like we're very happy to share. Some of them are just maintained in our lab. So for instance, we like I just said, we geo-referenced, a couple thousand historical maps, and we just don't have the capacity to like host those somewhere, because it's like, several gigabytes of data and things like that. But we're very happy to work with anyone to get those kind of things out there. And yeah, I would just encourage you to please feel free to reach out, and anything you're interested in. Yeah, we're very happy to get out there. We are just initiated the conversation, the start a project that's really focused on creating a central repository, not just for our work, but there's a tremendous amount of good work being done in this area. Some of the scholars, I mentioned today. And so, yeah, so the idea is to create a nice central repository that, specific to Hawaii and this type of work, we can kind of get everything in one place, to make it more easily accessible, so people don't have to go searching through on a wild goose chase. I do find the the move toward data repositories, I think, has been great in the kind of science world, but also a lot of times they're very hard to navigate, and there's like so much data getting in there so quickly that uh yeah, it's challenging sometimes. But yes, but please do reach out, and happy to provide you anything you're after.
Since this is a conference of professional geographers, perhaps somebody's listening who will take on that challenge of kind of simplifying the pathways for accessing data and that are held in a big repository. Elin Thorland from AAG says that any links NOAA provides will also be shared with the attendees after the events and so forth. And so we've got a long way from now to the April conference. And we'll find opportunities to kind of drop email links and emails and other links into the website for the conference so people can access information. But you've presented, my gosh, a lot of information. I want to qualify one thing that you said at the end. I thought was profound, that our smallness led to our big ideas. But it was also our smallness and yet our diversity, wasn't it? Isn't it, Noah? Because as compared to an atoll in the South Pacific, we had the high islands, we had the windward leeward, we had things that really allowed, we were small, definitely by any scale, but we had just enough diversity as well to kind of really lead us to there. That's what makes Hawaii so special.
I think that's what makes Hawaii, yeah, definitely special and like exceptionally studyable. But I do think a lot of the small islands, even ones with very low diversity, Tikopia, or there's some place like that, there might not have been as many different evolution pathways, but I do think they, in some ways, faced even harder truths, and have a tremendous amount to offer in terms of big outcomes, and I don't want to start down that path, but I think there's amazing parallels when you look at a lot of these small islands, and some of the contemporary things that are happening, and a lot of times they're not, they're not always pretty.
No.
And I think that's a big part of the lesson too. Like there are hard choices that need to be made, and that we can't shy away from those hard choices forever, or else they get forced upon you by our environments. And so yeah, I agree and disagree with that
The
last
similarity
point.
goes back to what I strongly agree with. I think you hit it on the head, that islands as places that you can't escape from,
Mhm.
whether they're smaller than us or the same size as Hawaii. And I thought that was because a lot of people are escaping to our islands with different agendas. There's, and changing things. So more on that later. But we have one last question from Doug Faulkner. What are the challenges and opportunities for agriculture in the future in Hawaii to be predominantly one of walking intelligently on the land? Can Hawaii show the rest of the earth the way?
Oh man, I hope so. Oh man. I mean, you've seen our farm, Doug, and what we're trying to do there. Um, yeah, I mean, I believe so, and I believe it's going to be less again in the specific practices, is more about, again, I think the process, right, of how you get there. And where I think Hawaii is really strong today is in a huge number of leaders that are really driving the value-laden discussions in terms of how how business is conducted and how land management is going. And those are the important things. Like, I think there are an infinite number of potential outcomes, of potential paths. And so it's not prescriptive in the sense that, you have to do this here. But I think the process of the decision making is the really, really important piece. And that's, again, where I think we are very blessed with some extremely provocative and well-spoken and thoughtful cultural leaders that are really bringing those discussions to the forefront.
And we brought some of them here through the webinar series, and there'll be more at the conference. So, Noa, thank you. This is a tee up. We'll see you again at a future webinar with a larger team, kind of looking at sustainable food systems again. So for those of you who are interested in this topic, there's going to be more in the webinar, and that'll be in the early part of 2024. But thank you, Noa, and thanks to all who participated in the live version of this webinar, as well as watching it online in preparation for the conference. It's an excellent presentation, Noa. Mahalo nui.
Aloha.
Aloha.